today our concern is about the 8086 microprocessor. First of all, we are gonna see its general specification. First of all, it is the 16-bit. 8086 has 20-bit address bus and can access up to 2 raised to power 20 memory locations, which is equal to the 1 MB. It can also support up to 64K uh, IO ports, which is input output ports. It's also provide 40 into 16-bit registers, and it has multiplex the address and the data bus, which is 80 to 8015 and 8016 to 8019. Further general specifications are that it requires a single phase clock with the 33% duty cycles and to provide the internal timings. 8086 is designed to operate in two modes, which is minimum and the maximum mode. It can prefetches up to 6 instructions byte from memory and queues them in the order to speed up the instruction execution. It also required the plus 5 volt power supply and a 40 pin dual in the line package. So the architecture of 8086 also consists of the two independent functional unit, which is bus interface unit and execution unit. First of all, what is bus interface unit and its operation is that it fetches the instructions or the data from the memory. It also writes the data to the memory and write the data to the port, and it also reads the data from the port. So what are the functioning of execution unit? The functions that include it is to tell the it's tell the BIU bus interface units to where to find the instructions of the data from, also to record the instruction and to execute the instruction. So the EU contains the control circuits to perform various internal operations and are decoded in EU. It's decode the instructions, fetched memory to generate the different internal and external control signals. It also required to perform the operations. EU has 16-bit ALU, which can perform arithmetic and logical both operations on 8-bit wall as well as 16-bit. So what are the general purpose registers that are used in 8086 processor are AX, which is accumulator register. It is the preferred register which is used in arithmetic logic and the data transfer instructions because it generates the shortest machine language code. BX, which is the base register, and it's a an address register. Next we have the count register that is used for the count loop and used in the shift and rotate operations. Data register is used in multiplication and division operations, and it's also used in input-output operations. Next, we have the pointers and the index registers, which is stack pointer, base pointer, source index, destination index, and instruction pointer. These are all are the 16-bit wide, and LH bytes are not accessible. So used for these used as the memory pointer, for example, MOVAH, which move the byte stored in the memory location whose address is continued in the register assigned to the register AH. So IP is not under direct control of the programmer. Next we have the special purpose register, which is IP instruction pointer. It's also always point to the next instruction to be executed and offset address relative to the CS. IP registers always work together with the CS segments registers and it point to the currently execution instruction. Next, flag register in EU is of the 16 bits flag, which have the 9 flags, and they are divided into two categories, which is conditional flag and control flag. Conditional flags are the flags that represent the result of the last arithmetic or logical instruction executed. Conditional flags are also as follow: they are carry flags, auxiliary flags, parity flag, zero flag, sign flag, overflow flag. Next, we have control flag, which are the set or reset deliberately to control the operations of the execution unit. And control flag, we have control flags are trap flag, interrupt flag, and direction flag. So that's for it today. Next we are gonna discuss the 8086 programmers model.